Welcome to another exciting episode of Cool Pods, a podcast series brought to you by Cool Earth Connections. I'm your host, Deepa Kulkarni, and today with me is Professor Edward Kosior of NexTek Ltd. He prefers to be called Ed. Welcome, Ed.
Thank you, Deepa, and thank you for inviting me onto your podcast.
Oh, it's absolutely a pleasure. So to begin with, for our listeners, I would like to introduce and give a little bit of background on Professor Kosior, Ed. So he has over 40 years of experience in the plastics and rubber recycling technology. He joined Visy Industries based out of Melbourne and Sydney, Australia in 1997 as a senior research and development manager. He is the founder of NexTek Ltd in London, which he launched in 2005. Apart from that, he has also been an advisor and consultant to various Fortune 500 companies. So it's my absolute pleasure, honor, and privilege to have him with us here today. So welcome again, Ed.
And thank you, Deepa.
And really looking forward to talking to you about your wonderful journey into the world of recycling plastics to create a positive environment for our Earth.
Thank you, Deepa.
So how did you come up with the idea to launch NexTek, and what was the driving objective behind it?
Okay. Well, prior to me working in the business sector, I was an academic for 23 years. I was a professor at Royal Melbourne Institute of Technology in Melbourne, Australia, and I ran the Polymer Technology Centre. And there we trained polymer engineers and technicians on how to make more plastic packaging faster. But it was very apparent to us that the real end destination of these plastics was not very good. It was mainly being used in packaging, used quickly and then discarded. And of course, lots of products go into building, automotive, electronics and medical are where they're used to their high value. But 40% of the world's production went to short-lived items. And I decided to put recycling as my focus for research. And so we were quite successful in tackling some of the big issues. And also, I have to say, we tried to recycle rubber, where we got to a certain point, but nonetheless, we could see the big issues and the need to research. And then I realized that if I was ever going to make a contribution to changing what was happening in the world, I needed to move from academia into the business world, where things could be done based on economics and the scale of impact could be much larger. So I used my background in polymer science and polymer engineering as a way of improving the technology and the properties of recycled plastics.
Well, that's wonderful, and that's how you created NexTek Ltd.
Yes, so in fact, there was a little bit of a journey. I worked inside, as you mentioned, Visy Industries as the senior researcher, and we built 3 recycling plants in Australia at different times. But then we were invited to design a plant for London, but it turned out that London became our base for the next 16 years, and that's where we started NexTek Ltd. And we worked on many projects to boost recycling, primarily because Britain was so far behind. They invested a lot of support into businesses developing new technologies and taking ideas to commercialization. So for me, it was the perfect storm, the perfect opportunity to do exactly what I wanted with businesses and governments who were already tuned into that wavelength, that they needed to do something urgently about plastics at the end of life.
Okay, that's really great. And could you talk about some of your past technologies and the impact they have created in the area of recycling plastics?
Okay, yes. So we've done a number of interesting things. So in about 2007, one of the technologies we developed was to recycle milk bottles, plastic milk bottles, back into milk bottles again. So this was previously an area of great interest, but it hadn't been commercialized. So that technology of making post-consumer plastics into food grade was probably a world first in this area. And now we know that there are billions of milk containers that are recycled literally every year through this technology in the United Kingdom. And there's something like 35,000 tons of milk bottles going back into milk bottles every year. So that was very significant for us.
That's
Um, yes, and the good thing is it happens every day, very safely, and every bottle has at least 35% recycled content, which is a big plus for the dairy industry to take that initiative. And the big thing was they held their vision firmly. They set their vision to do this, and they stayed with it. The other thing we did along the way, we developed concepts for unscrambling mixed plastics. So when people sort plastics materials out, they usually select the PET, and then they select the high density polyethylene natural, which have good markets. But we then developed technologies to separate the balance of the materials and to add value to those. So over time, we've developed some new techniques in this area. One notable one, especially for colored and plastics that we use for detergents, these materials often have an odor at the end of recycling. So we've developed a deodorizing technique where we can actually extract the fragrances that were absorbed by the plastics. And so we can actually eliminate those fragrances as a part of a recycling operation. This means those plastics can then go back into products that go onto the shelf. Now, if this hadn't happened, then the odor in those plastics would first of all smell in the supermarket, which consumers wouldn't like, but also it could permeate into products, which the brand owners would not like either. So one other thing which I think will be of interest is, as you know, black plastics are not recognizable by automatic sorting equipment. And that's because the carbon black absorbs all the wavelengths of infrared, which are used to do the separation of mixed plastics. And so as one of the challenges we had, we developed a black pigment that looked black but did not absorb in the infrared, which meant we now have pigments that can be black but are automatically sortable. Now, that idea has now spread to many countries, and many companies are using this concept that we developed probably over 10 years ago as commercial pigments to actually put this into packaging. So that I think was a major contribution we've made in that area. And one other thing we've done, which is relatively recent, not recent, but we've developed a process for recycling polypropylene back to food grade. This is, in many cases, polypropylene is the missing polymer. We all know about recycling PET and recycling polyethylene, but where is polypropylene? It's the world's biggest single polymer that's produced. 20% of the world's production is polypropylene, and that adds up to nearly 85 million tons a year being made in polypropylene, but the recycling rate is only 5%. So we have developed a process to make food grade recycled polypropylene, and we're expressing that in a new business and a new project called NextLoop, with a double P on the end of loop. And that's to encourage companies to recycle and use polypropylene. Now, there's one more technology that I'll mention, and that is the development of fluorescent markers. Now, when you sort plastics, normally we use the molecular signature of those polymers to differentiate between one material and another. But when it comes to materials like polypropylene or high density or PET, how can we tell the difference between something that was used for food or something that was used for detergent or a cleaning agent or a herbicide? And the answer is we currently can't do that. We need an extra parameter to sort these materials. So in some other research we did, we developed a new technology which was to use invisible inks on labels which fluoresce under ultraviolet light in the visible spectrum. So a label that looks like a conventional label all of a sudden might appear to be blue or yellow or green or red under ultraviolet light. Now, and we can code fluorescence. So once the fluorescence is decoded, we can then identify this as a food grade or a non-food or a toxic material, and we can separate on that basis. And this technology now is being used for the sorting of food grade polypropylene and non-food grade polypropylene. But equally, we could separate plastics that are used for the automotive industry, where often they're black. So we can put a marker onto black plastics and separate them based on their original polymer type. And the same in the electrical and electronics area. And this is actually quite important because those materials are often very mixed in their composition, but this marker would actually allow them to be tagged, identified, and separated.
Okay.
So they're probably things that we've spent lots of time doing, and we hope companies around the world do take advantage of these technologies and use them to keep on recycling plastics.
Okay, so basically, this is absolutely fascinating. I mean, you've done so much work, you know, and this is basically addressing the sorting and also taking care of how to avoid contamination as well, right?
Yes, that's right. So one is avoiding contamination, but also we can decontaminate plastic. So our project to remove odor from plastics is one step along the way. So when you think about what is in an odor, these are volatile molecules that have been absorbed by the plastic. Now we can extract those from the plastic, but if we amplify the extraction process, we can actually draw out even more molecules of high molecular weight. And these are the materials that we are worried about migrating into food. So in our process, decontamination is quite an important area. But I should mention, one of the main things we spend our time doing is designing recycling factories. So we develop technologies, but we also design the processes that go inside the factories and help optimize the performance of recycling plants. So the whole idea is that recycled plastic is as good as it can be. So as good as a virgin resin. So we can actually cycle these materials for new applications. And that means using less oil, less hydrocarbons, creating a circular economy that we realize that we have to build if we're going to eliminate the discharge of plastics to waste, to the environment, or to combustion. And these are all things that we can do if we just simply recycle materials. It's carbon footprint advantageous and reduces landfill and carbon emissions. So it's a very positive thing for us to do.
Oh, absolutely. I mean, this is fascinating. And so basically, you're trying to address the practicality and the safety aspects as well, not just aesthetics of recycled plastic packages.
Yeah. And the thing that happens, we also get involved in the aesthetics because when you use recycled plastics, they do have different properties. And so we work with converters, people who make new products, and we help them fine tune their processes to use recycled plastics. The thing is that recycling actually affects the properties of materials. It affects the flow behavior primarily. And what we do is we calculate and adjust the formulation of these materials so they are basically able to be dropped in as a replacement. But that fine tuning is actually important so that when companies buy these materials, they don't have failures. And so that if they're successful with recycled materials, they say, well, we'll do it again. But that means we have to use a bit of science and technology to make sure this happens and not do it in a random way, but in a structured scientific way.
Right. And that's what you're trying to do with the initiative of NextLoop.
Yes, indeed.
NextLoop.
That's correct. Yes, indeed. And next loop is something that probably could have happened earlier, but now is the right time to do it because globally we first of all have a big awareness of plastics and
Right.
the need to do something about them. But also now in Europe, there is now going to be a tax on single-use plastics of 800 euros per tonne. So the brand owners now will be having to pay a lot of money if they don't use 30% recycled content. So now we have the economic driver to encourage people to invest. Now,
Yes.
once we invest, we'll be able to do this in a continuous loop. And I think once we show the principle of looping plastics, then that concept can be used more widely. And the big thing for me is if we see plastics being reused, then people will say, well, why can't we do this more often for films and other materials that are ending up in the environment? So the model is let's do polypropylene really well, and then maybe we can do that for polystyrene and other materials that are on the margins and end up being discarded. So there's a very positive model coming out of all of this research.
Oh, absolutely. I mean, the way you've been explaining about it, it's absolutely fascinating. It's very actually encouraging and heartening to know this. Um, and
Yeah.
so,
And I think, you know, that's really my point when I ask myself, why am I doing this? Because often you have to spend lots of time, you know, you can be very busy doing lots of things with our team. We have a great team. The real reason is we have the scientific ability and we have the knowledge of what the future's going to be like if we don't do these things. And
exactly.
as, you know, as a citizen of the planet, I
Yes.
feel my duty to contribute what I can do. And the good thing is, you know, companies are recognizing this and they're engaging with us to design recycling plants. Every time we design a recycling plant, that's a huge plus because that represents billions of bottles that will go into a new life. So it's very encouraging, you know, especially when you get that support and interaction.
Absolutely. So, which are the different organizations and the companies that you have worked with in the past using all these different technologies? If you could mention some of them.
Sure. Yeah, I'm sure. So if I just go backwards from the very recent ones, it might be a good way of doing it. So some of the important ones have been, we've just designed a large recycling food grade PET plant for Cleanaway in Australia. And prior to that, we've designed a large multi-material recycling plant for Viridor in United Kingdom. And this one is probably will be one of the biggest in United Kingdom. Over 95,000 tonnes going in and 65,000 tonnes going out. We've designed plants in the United Arab Emirates very recently. We can't mention the name just yet. And then we've designed plants in New Zealand and Australia as well before that. And there are others along the way as well coming. But one of the other things we've been doing is we've been going to many countries to improve the quality that is coming out of some recyclers. So we've been to something like 8 South American countries where those recyclers have a very different paradigm to what we might see in USA or Europe, but they still run businesses and the quality has in general been what we might call average and not really suited for high quality applications. So we've gone to those companies and then in some cases reconfigured their equipment. We've boosted their operational practices to new strategies, and they've been able to reach much higher qualities. And the bonus for them is some of the global brand owners are now buying those materials from those plants. So this is really, this gives us hope that we have companies around the world that we might consider not highly developed, but they're certainly capable of making high quality plastics. And especially in those countries where they don't have formal waste collection and they collect in a different way, this is really quite important for this still to happen in those areas. So I'm sure that's for us going to have lasting legacy in those countries,
Yes.
because it sets a new standard and everyone else has to compete with this standard.
Absolutely. And I'm sure that is very gratifying to know that.
Yeah, indeed, indeed. And doing all of this work around the world has meant we've met many people, made many friends in all those companies, and we're constantly in contact with them. You know, so from Egypt to Tunisia, right across Europe, even Russia, and Mexico, and so on. So we have wonderful people who we know in all those areas.
Oh, great. So with NextLoop, do you at present have any companies that are involved in this project of yours?
Yes, yes, indeed. And we have something like 15 companies now that are going forward, and we're just on the edge of making an announcement of the names of these companies. So in about 10 days, we'll be able to release them. But we have amongst them very big brand owners, very big recyclers, a number of very prominent converting companies that want to convert these materials. And we're really enthusiastic about this project because this will become a new frontier for those companies. They will be able to offer a material to their clients in a really big way. So you can just imagine if you're a resin producer and your customers are saying, oh, look, we have to have 35% recycled content. Well, where will they get that from? They have to go to, you know, if you like, this new technology. So, and this is one of the big changes we're seeing. Virgin resin companies are now realizing that recycling is a natural part of their scope of supply. So we are seeing now a whole new world, and that's great to see as well.
Yeah, and you're like addressing the whole issue right from the beginning, right? You know.
Yes,
Right.
yes, indeed, yes. Well, that's what, perhaps we're closing the loop, indeed,
Yes,
or
yes.
creating the next loop.
This is absolutely great and fantastic. So, what aspects of designing and packaging do you think the companies, should keep in mind to ensure that the packaging is fully recyclable?
Okay, well, here I'm going to be very controversial. Most plastic packaging has never been designed to be recycled. So even if it says recyclable on the container, very often people don't think about what it is that's going to happen next. So if I give you a quick example, if we take a PET bottle, the PET bottle may have a closure on it. Now, in the world, that people will use high density polyethylene or polypropylene. And both of these materials, once they're mixed together, they're very hard to separate out. So why doesn't the packaging and beverage world decide which one to use? Use one or the other. And yet, you know, the world's divided. So that's a very simple error we make in that. And if we take the area of things like labels and glues, many labels are glued onto bottles. The glue behind the label actually causes a lot of contamination and discoloration in the recycling. And I think the label companies have got to do a lot more development to make sure that labels come off with the glue and get separated out. And just going back to the area of caps, every cap should be attached to the bottle. No cap should ever be, you know, more than a few millimeters away from a bottle, so that when it's recycled, the cap goes with the bottle. Millions and millions of caps get lost to the ground, to the rivers, to the oceans, and then go. You know, so tethered caps will be a feature in the future. And so, and just thinking about the plastics themselves, many polymers are only stabilized to be recycled once. So when they first go through their mechanical recycling process, they get oxidized thermally. And so they're not stabilized sufficiently to be reused. So this is another important thing. So when we think of colored plastics, there are so many packages that are colored But when they're recycled, they end up being, of course, mixed with other colours. They end up with a grey. And then if you go to the brand owners and you say, what would you like to buy from the recycled plastics? They say, clear plastic, please.
Yes.
And I ask them, how much clear plastic do you make? Oh, we don't make any clear plastic. So you know, if they want clear plastic, they have to make their packaging out of clear plastic. And of course, many of them put big labels over the package disguising the colour. So we have one package which is very prominent, which is bright pink. And then they put a label that goes all the way around, and then you can see very little of the package anyway. So why are we putting expensive pink pigments into plastic that makes it non-recyclable and then put a big label on it? So here's my point. I believe we should have what I call naked plastics. So plastics with nothing else. Make the plastic, make it ready to be recycled. Don't put pigments in it. Eliminate the glue from the labels. Make sure things go together. Make sure we get high yields. We rationalize the polymers that are going to be used in design, and really, really think that when we put this package out, it is actually going to be recycled, and think about the problems we're creating when we put it out. One of the things that people don't think about right now is the white pigments that are going into PET bottles. Now, there are many of these going onto the market, and putting the white pigment dooms that plastic to landfill or incineration, because they're, in general, not being recycled. Clear ones are, the other ones are not. So these are just simple marketing choices that brand owners have to embrace. So the problem can be solved instantly by design. So then it makes recycling easier,
Yes.
more profitable, more material gets recycled, less goes to landfill. So we've always said recycling starts with design, and we can solve so many problems just by changing what we do at the very beginning.
Wow. Yeah. I mean, that's fantastic approach. You know, what you mentioned about having plastics to be clear without any pigments.
And it's so simple. And you know what? The businesses will save money.
Yes. Yes. And we don't need them, right? I mean, we don't need as pigments plastics.
The marketing people say they do, but in reality, there are other ways of putting attractive, you know, put labels on that come off easily, but use the label as the marketing tool. But you don't need to put it into the product. But we know some, for example, some companies pigment their bottles because they don't want people to see the murky material inside. They say, no, we don't want to put them off because it's all murky. But we drink it anyway. So, you know, is that really great? They're hiding their product. But I do know it's a marketing thing, and things are complex.
Yes.
But clearly, because we have a crisis, if businesses want to use plastics, they've got to get the message to the consumers. For example, we're making this clear because this boosts the recyclability of the material. And people will say, okay, that's great. We like the label and so on. But the plastics industry is under real pressure now, because if they don't solve the recycling issue now, we'll be switching back to glass, back to paper, back to many other materials that we used before. And these materials could have a higher carbon footprint than plastics, simply because we haven't addressed the recyclability.
Yes, exactly. You don't know where they're going to end up and stay there forever and ever.
Exactly.
Well, that's a very interesting approach and a very new way of looking at things.
Yes. Well, I think you know, we've closed our eyes before. Now we have to open our eyes and really work on these topics in a real way. And the good news is we have lots of companies going down that track already. So everything started. We just have to keep going.
Yes. Yeah, and that's really heartening to know that you know, so many companies are coming up and taking such wonderful initiatives.
Yeah.
So regarding NextLoop, when do you think you expect to have your first plant operational?
So our plan is to have the first plant operational in 2022. And that's the first plant we plan in Europe. However, we've had companies come to us who are even more eager. So we may even get one nudged into 2021. It does take approximately a year to organize this. And we've now got something like 4 organizations that wish to build next loop recycling plants. So it'll be a matter of those individual businesses setting their time frame. But the earliest will be the end of 21 and then into 22.
Wow, that's wonderful. That's not too far, you know.
No, no.
Yeah. Well, it's been absolutely wonderful talking to you, Ed, and really wish you all the best with all that you're doing. And, you know, let's all have great success with all this.
Well,
we can, you know, create a very positive impact on the environment. And it's great to know that you're so passionate about the environment, and I as well. And that's the whole point I started this series.
yes.
So it's absolutely been a pleasure talking to you.
Thank you, Deepa, and thank you for taking this on as well, because we need people like yourself who are good communicators to tell people about what's going on, because education is one of the things that helps everybody think again. You know, I always say that our problem starts when we go to what we call our waste bin. We should always be thinking, why am I putting this in the waste bin? You know,
Yes.
and that's where, you know, because that's actually the wrong bin. The right bin is the recycling bin, and we need to make our products so that everything gets recycled. Anyway, but thank you for the invitation and the opportunity to share my ideas and what we've done. It's been a pleasure to have the podcast with you.
Oh, thank you so much. And to our listeners, you know, hope you have enjoyed listening to Ed as much as I have enjoyed hosting this. If you need more information, you can please go to my website. It's coolearthconnections.com, or you can go to sustainablepackagingservices.com. And we are also having this podcast on Apple podcasts as well, so you can listen to them over there. And thank you once again for being here with us. Have a wonderful day, and God bless. So, I'll have Sandeep here. So that was wonderful. I am thrilled to see what you're doing and how much you have done, because we never had a chance to see that, right?
No, no.